Hello and welcome to my video 8.1, Tangents and Triangles. First, we're going to just assume that all of these lines are perfect tangent lines and that we are drawing it correctly, okay? So just assume that this is drawn correctly, so let me explain what that means. A tangent line is any line that just touches on one point on a circle. So just where I drew in yellow there. So just one point on a circle. So I can draw a tangent line like this, but look, in my non-perfect drawing, it looks like it's actually touching two places, whereas this line should only touch in one point right here. So if you can see it in two places, best thing is just to go in the middle. Okay, middle of what you can see. So here we can sort of see that it's touching from here to here. So, you know, roughly in the middle, and that's what I tried to do. Whoops. So we have roughly the right idea. Oh dear, I'm just going to leave that one there. Okay, so we have roughly the right idea. So this question says, what is the length of the missing side? Oh, the other thing is, if you see a smiley face like this in purple, then this is the center of our circle for the next few videos. So this is important. Everything has to be going to the center. So center of our smiley face, the nose is the center of our circle. Okay. What is the length of the missing side? So we have one side here, and the question is, what is this side? And that's not so bad, except that we have to know something before we can do that, before we can even get that other side, because we need to know that this is 90 degrees. And that is just a rule that we're going to have to believe in. We go through it in class a little bit more in depth, but that's just a rule you're going to have to believe in, that is 90 degrees, where the line perpendicular to the tangent line, so that's the blue line there, is going 90 degrees to the tangent line, so that's perpendicular, and it goes directly to the center of the circle. Okay, so that would be the radius, the blue line. Okay, blue 6 here is the radius of our circle. So that says that our angle here is going to be 90. And if that angle is 90, if we have a right angle triangle, and I want you to spin your phone or Chromebook or laptop around and make sure that you can see that this and this are the same drawing, just spun around. If that's 90, then we can see this rule, ABC, which is called Pythagorean Theorem. So this is a squared plus b squared equals c squared. Pythagorean Theorem. That's really important. So now that we know that, we can use 6 squared plus 8 squared equals c squared. C is our hypotenuse, or our longest side in a right angle triangle. And so then we can work it out. We're going to get 36, 64 equals c squared. C equals the square root of 36 plus 64, which is 100. And the square root of 100 is 10. So c is 10. And this is actually a really cool set of numbers. It is based off of our perfect ratio for a right angle triangle. That is 4, 3, and 5. That's our perfect ratio. If you multiply by 2, it still holds true. If you multiply by 3, 4, 5, doesn't matter. 1.5, it still is the case. So if you can multiply 3, 4, and 5 by any number, this will be true. Okay, so we have that wonderful value here. So now let's look at a different question, but remember it's the same type of question. It's the same idea. So let's, well actually no, the last one's going to be the same. This one is an angle question, so this is not Pythagorean theorem. This is, I call it angle sum theorem. Angle sum theorem, which is that all angles add to 180 in a triangle. So this is not just a right angle triangle. This is any triangle, okay? So in this case, it's really helpful to know that this is 90, right? Because it's a tangent line, because it's to the radius, or to the center, we know that's going to be 90. Just in the same way we knew that was 90. But we can now use our angle sum theorem to go all the angles, A plus B plus C equals 180. And let me just draw out a triangle here for you. So any triangle at all. Oh, actually, let's draw a different shaped triangle. A, B, C. So all the angles inside should add up to 180. So in this case, what I would do is I would go 180 minus 90, because we know that, and minus 35, because we know that, equals x. And then if we actually try that out, it would be 55. So x would be 55 degrees. Okay. Last question. This is going to be like the first question, but a little bit more complicated, just in the way that it's phrased. So first of all, we want to recognize this is a right angle triangle. This is the whole point of this unit, or this topic, sorry, is to recognize all tangent lines form a right angle to the center of the circle. So that's the point of the topic, but you can see it in different ways. So this is a right angle triangle, and we're being asked what the radius of the moon is. So let's label this R for radius. And actually, green is also R. Right? You should be able to see that. Radius is from any point in the from the center of the circle to any point at all on the outside. So let's get rid of those. So what we have here is actually still Pythagorean theorem. So let's just draw this out. A squared plus B squared equals C squared. Good. Let's fill in what we do know and see what we don't know. So A is R squared plus B is 300 squared equals C, which is actually R plus 25 squared. All right, so we can see that we actually are going to have something funny going on here, and we're actually going to use multiple units all into one to figure out the answer here, because this can be broken up into, so this stuff stays the same, R squared plus 300 squared, but this one can be broken up and written down like this, into two separate sets of brackets. Which then, I'll use a different color pen, but R will multiply at R to 25, so this is called distributive property, and then 25 to R, and then 25 to 25. So let's start out with the blue ones. R to R is R squared, R to 25 is 25R. Let's go to the red ones. R to 25 is 25R, and 25 to 25, hold on, let me just punch this in. 25 times 25 is 625. So I would be using a calculator for those calculations, but you don't absolutely need it. It just makes things go much faster. Okay, let's try the other side. We have R squared. We can't do anything to simplify that, but we can simplify 300 squared. So 3 times 3 is 9, and we add all the zeros. So 1, 2, 3, 4 zeros. So you could plug it into your calculator, or you can do it this way. Okay, so this is what we have so far. And what's really amazing here, this is going to blow some of your minds, but we get to, look, minus r squared. And if we could do it to one, if we do it to one side, we have to do it to the other, minus r squared. Now what's amazing is it cancels on both sides. Okay, that's awesome because now it's really simple math. So let's stick with the simple math here. Let's choose a new color. This here equals 50r plus 625. From here, it should become obvious. Okay, these other steps are high level grade 9, but this is where it starts becoming quite obvious. Now we can see, well, we subtract 625, subtract 625. If you do it to one side, you have to do it to the other. So we're left with, okay, this is going to be a big mess of numbers. 4 minus 8, 9, 3, 7, 5, and 50r. Okay, we're getting close to a value now. Now we're going to get, whoops, let me write it down actually. It's a bad habit. Okay, so those cancel. Now these cancel. We're left with r on this side, and to simplify that, we get 1787.5. And that is our value for r. And what's interesting is our calculator doesn't really, show this very easily. Even if you plug this in, it's not going to quite get it because it's going to be rounding errors and stuff. This is the only way to do it nicely by hand. So this is r here, and this is our answer. So I hope that video helped, and good luck with tangents, Pythagorean, and angle sum.